All right, so here we go with part 4 of section 5.1. In this section, we're going to take a look at the idea of this concept of initial conditions and particular solutions. All right, so we've already taken a look at the idea of a function y being an integral, an indefinite integral of a integrand f of x, and that it has many solutions, that those many solutions always differ. They always differ by a constant. And we talked about this before, how basically what it says is that these graphs are just vertical translations. So for example, if we say that y is equal to the indefinite integral, there's my operator, of the expression 3x squared minus 1, that indefinite integral is going to be x cubed minus x plus c, where that c is going to just yield some sort of a vertical translation. And this picture over here on the right, this graph that I created, is just that function x cubed minus x plus c for a whole bunch of different values of c. And so for each of those different values of c, we have just created a different vertical translation. You'll see that the shape of the graph is exactly the same in every single one of these. It's just a vertical translation. Now, if you need to know if you're one of those people, look at the y-intercepts. This is crossing at about 1, so that's when c is 1. This is when c is 2. This is when c is 3. This is when c is 0. This is when c is negative 1. This is when c is negative 2. This is when c is negative 3. Just different values for c that I put in. Right? Now, for some applications, for some problems, what we need to do is we need to find not the entire family of solutions that we're looking at here, but we need one of those solutions. We need a particular solution. But in order to find the particular solution, in order to find the graph that we want here, what we have to do is we have to know a point that graph passes through. And that idea of knowing that point to give us the proper vertical translation is the idea of knowing an initial condition for our function. So let's say that we knew this point right here was on our solution, on our particular solution, that we know that we have to slide that graph vertically. Remember, it's not a horizontal translation, it's a vertical translation. That we would just slide that graph vertically until the graph passed through that point, and then we would find the corresponding c value. Essentially, if we know that that point is some point x sub 1, y sub 1, we're just going to use those in that equation and say then that y sub 1 needs to be equal to x sub 1 cubed minus x sub 1 plus c. And since these will be known numbers, we can easily solve for the c value. And so that would be a solution to a first-order differential equation initial condition problem. And why is it a first-order differential equation? Well, because we could rewrite the original statement up here and say that y prime equals 3x squared minus 1 with the initial condition of whatever that x sub 1, y sub 1 is. And when you solve this, you're going to get this equation right here with the known value of c. Okay? Now, when you take your differential equations class, this is what you're going to be doing. They won't be this easy. They'll be much more complicated problems. And you'll have first derivatives and second derivatives and third derivatives and initial conditions of the first derivative and initial conditions of the second derivative. You'll have all sorts of things dancing around. But it's the same basic idea. I can take an indefinite integral and get a function. But that function, when properly expressed, is going to have that plus c on the end, which is going to mean you're looking at an entire family of solutions. Okay? Now, just to be clear, this picture over here is not all of the solutions. This is just a subset of those solutions. And then the initial condition narrows it down to one of those. So let's take a look at an example. Our job is to find the particular solution for the first-order differential equation y prime equals 3x squared with the initial condition 2, 4. Hey, this is just the problem we are working with. Right? If y prime is equal to 3x squared minus 1, then what I'll do is I will integrate, on the left with respect to x. I will integrate on the right with respect to x, and that will give me y. is equal to x cubed minus x plus c. Now I'm going to use that initial condition to figure out that c value. So I know that y is 4 when x is 2. All right? I'm going to drag this right up to here. So 4 equals 8 minus 2 plus c. So c equals -2. But this is not the answer. The answer is a particular solution, and a particular solution is this with that specific value of c plugged in. So the particular solution is y equals x cubed minus x minus 2. This is the one that passes through the point 2, 4. It's this graph right here, that red one, because it passes through the point 2, 4, which is right there. And if you trace that back down, you'll see that it has a y-intercept. Oops, 2, 4 right there. It has a y-intercept of -2. Okay? All right, so what we're looking at here is we're looking at finding a particular solution. All this means is take an antiderivative, take the indefinite integral. The indefinite integral is generic in the sense that it has a plus c on the end. Use the known point on the curve to narrow that down from infinitely many to the one that goes through the point. Okay, we're going to try this again. We're going to find the particular solution for this, and this will be our last example. We'll be done with section 5.1. Find the particular solution for the first order differential equation y prime equals 4x minus 1 with the initial condition 2, 4. So I'm going to take the integral of y prime with respect to x and the integral of 4x minus 1 with respect to x. Left-hand side becomes y. Right-hand side 4x. Let's see, that's going to become 2x squared minus x plus some unknown constant c. Right? Plugging in the initial condition, I get that 4 is equal to 2 times 2 squared minus 2 plus some unknown constant c. So 4 equals 8 minus 2 plus c. Did I set this one up so it's going to give me the same answer again? C equals -2. Okay? I hope that you don't look at this and say, well, both of his answers were -2, so the answer is always -2. That was just me being dumb. I should have picked a different value. But then putting it all together, I get y equals 2x squared minus x minus 2 as our particular solution for the first order differential equation y prime equals 4x minus 1 with the initial condition 2, 4. All right. And that brings chapter 5, section 1 to a close. I'll see y'all back here for 5.2.